So, we are going to work these review questions first, and then we're going to go a little bit more into the law of cosine today, which are very, very simple. How many of you had your trig class last year? Okay, that's more than first period, but there's enough in here that haven't had it at all, so we have to start at ground zero with that, okay? And we talked about sine, cosine, tangent, cotangent, secant, and cosecant yesterday, right? Okay. So here we go on this first one. Give the matrix A that you would use to determine the quadratic with points -1, 5. What else? We have 2, 0, and 3, 11. Thank you. So I heard Edie talking about what a quadratic was, if she knew that it had that square in it. You need to know those things. These have to be part of your repertoire of skills that you're able to pull from and know what a quadratic is, and you're not going to give me y equals mx plus b. Okay, that's important. Your quadratic can look one of two ways. Y equals ax squared plus bx plus c, that you're kind of used to. It's called standard form. And your quadratic would be in this format if you wanted to use your quadratic formula. Yeah, you'd pick your a, b, and c out of there in order to do that. Okay, or it could possibly be in the format for y equals a x minus h quantity squared plus k, which is what I call vertex form, because the h and the k are the vertex of the parabola. This is something you should already have been playing around with. I'm just going to give you a quick example, something like that. That's a parabola, and I hope you recognize it to be a parabola because of the squared function in there. And the y is not squared, but the x is. So you should notice this as being a transformation, which would be a horizontal shift to the left by 3, and then down by 4. Okay, we learn these transformations so that we can play around with this. And what's this 2 do? It's a vertical what? It's a vertical stretch. So this parabola is going to be twice as narrow than the original y equals x squared graph. So you're going to go left 3, let me see, 1, 2, 3, and then down 4, 1, 2, 3, 4. Your vertex will be here, -3, -4. And it's going to be kind of narrow going up, right? And that's basically the idea behind your quadratic right there. However, when it's like this, we can do a lot of solving for x, a lot easier. So we're going to go to that second thing. We've done one of these questions before. If you review your notes, you'll see it. Have you looked on your warm-up so you see where this gets done using matrices? So I want to use -1, 5 first. This is my x, this is my y. Simply put it into the general form of a quadratic and leave it in terms of a, b, and c.
This fits in. Yeah.
Thank you, Jasmine. 15. Okay. So if I put my 15 right in here, I get 15 equals the a I don't know, -1 is my x, you square it, plus b I don't know, -1 is my x, and then plus c. So you take one step, you simplify this, but don't forget that the answer should be on the right-hand side. The answer should go on the right-hand side when you're done this. So if I take -1 and I square it, I get 1. So this is 1a. Talk to me, hurry up. Minus 1b plus c equals 15. Now we're going to use the next point, which is what?
2, 0.
2, 0. And we're going to do the same thing, okay? We're going to put the 0, and this is my x and my y. We're going to put the 0 in here. 0 equals my a I don't know, but I know my x is a 2, so 2 squared, plus b. I don't know my x, I don't know my b, but my x is a 2, so I put my 2 in there. And then plus c is my other unknown. So I'm going to clean this up and make it neat, and I'm going to put my 0 on the other side. What do I write? 4a plus 2b. I'm going to use my last point, which is the point of 311. And this is my x and this is my y. Go right into the original. We go y first. So we have 11 equals the a I don't know, so I just write a. The x is a 3, so 3 squared. Plus b I don't know, but the x is a 3, so times 3. And the c I don't know. Clean this up, make it neat, put the 11 on the end on the other side. I write what?
9 plus 3.
Good job. So these 3 equations need to go in for matrix A. Tell me what to write here. By By the way, this is an A column, B column, C column, and then answer column. Go.
1, -1, 15,
Go.
4, 2, 1, 0, 9,
Okay. And then this is the answer to the warm-up question. All I did was ask you to set it up and give me the matrix A that you're going to use in order to pop that in your calculator and give the answer. How do we go about finishing this? I know you don't have your calculators today, but tell me how you do it anyway. Second matrix. I'm going to edit. What size is this?
4 by 3. 3 by 4.
It's a 3 by 4. If by chance you put it in backwards, you'll notice it, won't you? Because it won't be the same array of what you need. Okay? And when you get done with this, you got to make sure to go back into your matrix, go over to math, and calculate what. Maybe go over to calculate. What is it? What choice number am I looking for? The dogs, right? The big dogs. What dogs? What do they say? What do they say? They don't say R-R-E-F. What do they say? Say it on camera. I want to hear you. Rob. Yeah, okay, so R-R-E-F. Please, you guys, don't just do R-E-F. We want reduced row echelon form, not just row echelon form. And a set of parentheses will open up. And then, what choice number is this? Do you remember? What? B, because you're playing with the big dogs, right? Okay. So here we want matrix A to go in these parentheses. You cannot type a bracket and then A and then close your bracket. It doesn't work that way. You got to go back to matrix. The word names is already highlighted and your matrix A is already highlighted as choice 1. You press enter and then matrix A will show up like this. You press enter and you'll get your 3 answers out of the deal. Okay? Did you already do it, Monty? Is it on your calculator or no? No? Did anybody do it? Did you do it? Did anybody do it?
No.
No?
Do it real quick.
Can you? I know that only a few people even have their calculators. Let's got it all done?
Yeah.
How much you have?
A equals 4, B equals -9, and C equals 2.
Let me write that down, okay? So when you do this on your calculator, this is going to show up as 1, 0, 0,
4.
4, 0, 1, 0, negative 1,
9.
9, negative 9, and 0, 0, 1,
2.
2. Okay? Let's not forget, this is my A column, this is my B column, this is my C column, and this is my answer column. So basically this row is telling us that 1A plus 0B plus 0C is equal to 4. In other words, A is equal to 4. This next row is saying 0A plus 1B plus 0C is equal to negative 9. In other words, B equals 9, negative 9, sorry. And then 0A plus 0B plus 1C equals 2. Otherwise, C equals 2. What are we packing up here? Okay. So we're all good. Hopefully that's a good review for finding those things. There's definitely questions like that you need to know how to do. All right? Hopefully nobody has any more questions for me while I erase the board without asking you. Okay. All right. Second question that's up on the board, I want this done kind of fast. I gave you a 30 and a 60 and a 90. I said this is 18, 30 degrees, 60 degrees. I asked for X and I asked for Y. There's no work to do for this. If you recall the quote that I had on the board yesterday, who remembers that? What is it?
In the, oh, no,
In
no.
a,
Oh yeah, in the 30, 60, 90, the side opposite from the 30 degree angle is half of the hypotenuse.
so what letter do you know and how much is it?
X is 9.
You know that X is 9. Because the side opposite the 30, I call that my short leg, is always half the hypotenuse. The hypotenuse is 18. So therefore that's a 9. Alright, so you have 9 right here. And you can do the Pythagorean theorem to solve for y, or you can use that little trick that we talked about, the ratio of the sides always being 1 to 2 to the square root of 3. So what's my y? 9 times the square root of 3. And you're finished. And it's that fast. Question 3. This was 2. Alright. Question 3, I asked you to sketch 5 pi over 6 in standard position and give the value of alpha, which is your reference angle, in degrees. Okay? Where is 5 pi over 6?
In quadrant
It's in quadrant 2. Now this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. When we sketch an angle in standard position, we always start our initial side on the positive x-axis. We rotate counterclockwise until we go 5 pi over 6. Now see if you can do this with me. 5 pi over 6 is almost, say it, 6 pi over 6, which is a whole pi. So you're a little bit shy of touching this axis over here, right? How much shy are you? 30 degrees shy. You're pi over 6 shy. So it's going to bring you all the way over here, and you're going to be 30 degrees shy of touching that other x-axis on the other side. This right here is 5 pi over 6, and my alpha is 30 degrees for my reference angle. Your reference angle is always formed with the terminal side and the closest x-axis, which would be the one right next to it. Questions or comments there? Are you sure? Yeah. Yeah, you weren't here yesterday, right? So you have to watch yesterday's video, which is already up. Okay? And something else I want everybody to be able to do, I want you to be able to take 0 to pi and chop it into 6 pieces. In order to go from 0 to pi, I want you to chop it into 6 pieces. It's already chopped in half, so I need to chop each half in half. I want 6s all together. You already cut it in half.
Cut it in thirds.
Cut it in thirds now, right? Okay, so I need to chop this into 3 equal pieces. And I need to chop this into 3 equal pieces. If they're not quite equal, then you're going to have to go back and make them a little better. So this is 1/6 of pi. This is 2/6 of pi. This is 3/6 of pi, otherwise known as 1/2 pi. This is 4/6 of pi, and this is 5/6 of pi, which shouldn't surprise you that it's 1/6 of pi shy of being the whole 6/6. Got it? Okay, I want you starting to think about things in terms of pi. So where are we now? This next one, number 4, I think I'm going to leave number 4 for tomorrow. Okay? So I'm going to erase the board. I am going to do something with you called the law of cosines, even though we have about 3 minutes left. But I am going to hit it. It's that fast. It's that easy. Questions, Fantasia?
So I did it like I found the degree and then I subtracted 180 I subtracted 150 from 180.
And that's the logic behind it, okay? And I understand that you're going to be doing that. So it's like we're talking Spanish, right? Or some other language, and you're changing your language into English so you can work with it, and then you're going to go back and give the answer back again. I just want you to try and learn to live with pies as much as you can, okay? As much as you can. All right, so I'm going to erase this here. We're going to do as much as we can with this law of cosine real quick, like, and you can review this a little bit more tonight, okay? This is law, and I'll say laws, even though there's really only one. Okay? It's one of the easiest things we do in trigonometry. I think you'll like it. It's even easier than learning sine, cosine, tangent, cotangent, secant, cosecant, and that was pretty simple. Okay, any triangle, doesn't have to be a right triangle. You got 3 sides, A, B, and C. Notice they're all lowercase. And capital A is here, capital C is up here, and capital B is down here. Let's not forget, capital and lowercase are always across from each other. So I call lowercase a and capital A a pair. I call lowercase b and capital B a pair. And I call lowercase c and capital C a pair. All right, so if I have, let me see where I am. Let's say I wanted to solve for side A. With the law of cosines, I need to know everything around it over here. Not the C, not the B, not these angles, but I need to know this, this, and this to do it. Now, hold off with me. Let me do the first one with you. It doesn't say A equals, it says A squared equals, because this stuff comes from the Pythagorean theorem. Okay, so it says A squared equals. It's going to be just exactly what you think for the next two things. B squared plus C squared. Doesn't that look like the Pythagorean theorem? Minus 2BC, these are the two things you just mentioned, cosine of angle A. It is, of course, a law of cosine. You would expect to see a cosine function in it. And the angle A has to pair up with the thing you're trying to find over here, A, little a, side A. Let's try it again, ready? B squared equals, give me the other two sides. A squared plus C squared minus 2AC cosine of angle B. Let's try it again. C squared equals
A
squared plus
B squared minus 2AB cosine angle B.
Isn't that simple? Isn't that ready? Triangle JKL. I'm not even going to draw it. J squared equals
K squared
plus L squared
minus 2KL cosine angle B.
Yeah? K squared equals
J squared plus L squared minus 2JL
2JL
cosine of angle
capital K. Last one.
L squared
L squared equals
J squared plus K squared minus 2JK cosine angle capital.
So you should be able to do that no matter what three letters make your triangle.